So we're moving on to lesson 2 in chapter 9. So some data. This is actually going to remind us of some things we learned in chapter 4 and chapter 5. Equations of lines and y equals mx plus b. So we will have that for a reminder. So the lines of best fit are going to be in y equals mx plus b form, where m is our slope and b is the y-intercept. So that's just a quick reminder. We'll see that later. So name and date over here on the side. It says the table shows the average annual cost of 1 pound of chocolate chip cookies. So it says years since 2000, so we have some years, and then it looks like the price of the cookies has fluctuated, gone up and gone down some. It says what year corresponds to 0 years since 2000? Well, that would be the year 2000, because it's 0 years since 2000. What about 9 years since 2000? That would be 2009. So we're going to see questions like that later. If the data were displayed in a scatter plot, would the scatter plot show a positive, negative, or no association? So did the prices go up, down, or totally random? And it looks like they kind of go up and down, up, 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 but overall they go up. So there's a positive association. Prices go up over time. Would a more reasonable prediction for the cost of cookies in 2015, so that would be 15 years, so kind of out here, be $3.25 or $4? Well, I would guess $4 because that's still 6 more years, and it's already at $3.24, and it's kind of going up the last couple years, so my guess would be $4 to be more reasonable. We have a vocab word on slide 2, line of best fit. When data are collected, the points graphed usually do not form a straight line, but may approximate a linear relationship. A line of best fit is a line that is very close to most of the data points. So they tell us here in this little sticky note that drawing a line of best fit using the method in this lesson is an estimation. Therefore, it's possible to draw different lines to approximate the same data. And so I added, your lines and equations will probably be different. This is hard to grade, but as long as your answers are reasonable, I will know that you understand. So as long as our slopes are close and our y-intercepts, so close m, close slope, and close y-intercept, or b, we will know that you did fine. Okay, on slide 3, it says, refer to the information in the table about the cost of cookies. So there's that cost of cookies again. Here's the line. What does the y-intercept mean? So y-intercept in the y equals mx plus b is the b. That's where it starts on the y-axis. So at 0 years since 2000, it was at 259. So what does the y-intercept mean? That in 2000, the cookies were $2.59. What does the slope mean? Well, it didn't give us an equation, and we will later go and find the actual equation. But just in general, slope is m or y over x, so it's the average cost per year. So in general, it would be the average cost per year increase, because this is a positive growth. Use the line of best fit to make a conjecture about the cost of cookies in 2013. So that would be if we go, here's 2000, 2010, 2012, 2013. If we brought that up here, looks like they would be about, I'd say $3.35. Using the graph to help us there. Slide 4. It says, refer to the scatter plot about yearly points scored on a certain race car driver. Draw and assess a line that seems to best represent the data. So looking at that vocab word, it's very close to most of the data points. So we're going to draw a line through here that's close to most of the data points. So it looks like the majority of them are around here. We do have a kind of a cluster of points down here, but I'm going to draw a line somewhere going up above the cluster, but below there. And again, you could have different lines. This one might be more appropriate. They're different lines, but they can give us an estimation of the data. Use the line of best fit to make a conjecture about the points the driver will score in 2015. So 2015, but we're talking about 1999, so 2015 minus 1999, that's 16 years after. So we need to go 15. This would be 17.5, so 16. If we go up on our line, I'd say somewhere, even if we, either one of those, somewhere between those 2 points, I'd say about, that's shy of 7,000, so I'm going to say 6,800 points. Is going to be my guess. Now you might have said more than that. Just depends on your line. As long as your line is accurate or mostly accurate, it'll help. And I tried on your homework to be a little more specific. Okay, so the scatter plot shows the number of cellular services subscribers in the U.S. Write an equation in slope-intercept form. So that's y equals mx plus b for the line that is drawn, and interpret the slope and y-intercept. So we have to, 1, find this equation, and 2, tell me what it means. So choose 2 points. They may or may not be on the line. Find the slope. How do we do that? Plug and chug into the point slope form to help us. Or you can use this form. So 2 points. Looks like I'm going to pick this one. And, well, I want them to be nice, clear points. So none of these look like super great. This one looks pretty close. It looks like 127 maybe. And there's another ordered pair, 6 to 10. Most of the homework though that I have for you gives you exact points. Okay. So to find the slope, that's y2 minus y1 over x2 minus x1. So y would be 210 minus 127 over 6 minus 2. We can round this to a decimal. 210 minus 127 over 4. 210 minus 127 is 83. Divided by 4 is 20.75. So we'll just, let's just round the nearest whole number. It doesn't say. So we're just going to round. We're going to say about 21. So we now know that m is 21. So then we can pick one of our 2 points and put it into y minus y1 equals m times x minus x1. Or you can use this form and solve for b. So I'm going to choose my first one, y minus 2 equals m, which we got before was 21, times x minus x, the x coordinate of our ordered pair. Oh, geez, I wrote the wrong one here, 127. There we go. So we need to distribute the 21. Y minus 127 equals 21x minus 42. In order to get y by itself, I need to add 127 to both sides. So I get y equals 21x plus 127 minus 42 is 85. So there's my equation. Now it says to interpret the slope and y-intercept. So the slope is going to be something per something. It's going to be y label over x label. So that would be subscribers per year. So 21 subscribers per year since 1999. The 85 will represent at 0, so 0 years. So in 1999, there were 85, and it's actually a million if you look there, million subscribers. There we go. Okay. Oh, you know what? There was room for that over here. That's okay. So the y-intercept and the slope, we got that on on slide 3. So it's over there. Use the equation to make a conjecture about the number of cellular subscribers in 2015. Okay, so our equation was y equals 21x plus 85. All right, so we need to know in how many years in 2015 the amount of subscribers. So if we're talking about years since 1999, this is 16 years past 1999, and that label is on my x coordinate, so that's my x. So I'm just going to plug it in. Y equals 21 times 16 plus 85. 21 times 16 is 336 plus 85 is 421. So 421 cellular subscribers, or we can just write subscribers. And actually that would be million. So just plug and chug into the equation that you come up with. If we come up with different equations, the answer should still be reasonably around that number, which is where our estimations come from. Okay, so slide 7, last one. The table shows the expectancy in years of people born in certain years. So in 1900. So in 1900, 47.3 years old. It says construct a scatter plot of the data, then draw a line that assesses the that best represents the data. So on our x-axis, that's going to be years since 1900. And the other one is going to be the life expectancy. We're going to try to make little dots here because we have a little space here. So at year 0, their life expectancy is about a little over 45. At 10, it's a little over, or it's at 50. At 20, so up and over, it's going to be 54.1, so just below the 55. Almost to 60 for the next one. Or, sorry, yeah, almost to 60. Now we're at 40. A little over 60. At 50, we're at almost 70. At 60, we're at really close to 70. At 70, we're, there's kind of a slowdown there. At 80, we're at 73.7. 90, we're just over 75. In 100 years, so this would be the year 2000, expect to live to be 77, a little over. Okay, then it says construct a scatter plot, then draw the line. So this one's pretty close. I'm going to go through my first dot and my last dot, since all of them are going to be really close. And then it says write an equation in slope-intercept form for the line that fits. Okay, so we can just pick 2 points. And I'm going to pick 2 points that fall on my graph, or my line. I'm going to pick this one, which happens to be 80, the one at 80, so this one. And I'm going to pick, this one's really close to my line, so at 20. So a shorter way to do the slope is to find the difference here. So this is, and my difference here. This is my y over my x. So the difference between my y's is 73.7 minus 54.1, 19.6 years, or 19.6 age, I guess, over 60 years. And then we can divide those. So it's a very weird number. So let's just run the 10.3. So my slope is going to be 0.3. So 0.3 years after 0.3 years per year after 1900. So does it tell us to interpret that? It does. So my slope is going to be 0.3 years lived, more years lived, there we go, per year since 1900. Okay, now I gotta go and find the y-intercept, which is gonna be my b. So I can put it into y minus y1 equals m times x minus x1. I'm going to use my slope as 0.3, and I'm going to pick the smaller ordered pair, so y minus 54.1 equals, oh, you know what? We can stop here because we already know the b. Ours is going to be a little different. This is going to be my b. This is going to be where it starts on the graph, 47.3, but let's just see how far we get in more practice. X minus, what goes with 20, or no, 20. So if I distribute my 0.3, I'm going to get y minus 54.1 equals 0.3x minus 20 times 0.3, 6. If I add 54.1 to that, negative 6, we get 48.1. 48. Oh gosh. 48.1, yeah. And that would be y equals 0.3x plus. So we got a little bit off, but really, really close. But we already know what the y-intercept should be. Our y-intercept says that in 1900, the life expectancy was 48.1. But I would totally be okay with it if you recognize that this is going to be the y-intercept, that at order pair 0 something, you could have said 47.3 years in 1900 without going through this. I would have been okay with that. And then letter C says, use the equation to make a conjecture about the life expectancy for a person born in 2020. So in the years since 1900, this would be 120 years. So using our equation, 0.3 times 120 plus 48.1. So 0.3 times 120 is 36 plus 48.1 is 84.1. So years old. And we'll probably get there. All right. Never be ashamed of a scar. It simply means you are stronger than whatever tried to hurt you. Have a great day.